252 million years ago, something happened on Earth, after which the planet almost became a lifeless rock. We all know about the asteroid that killed the dinosaurs. This story has become part of pop culture and children's encyclopedias. But few have heard of a catastrophe that was so terrible that paleontologists gave it a blood-chilling name. The Great Dying, an event that destroyed 96% of all life in the ocean and 70% on land. The asteroid that killed off the dinosaurs wiped out about 3/4 of all species, and we consider it an absolute disaster. The Permian Extinction wiped out almost everything, and life on the planet had to start almost from scratch. To understand the scale, imagine the world that existed before this disaster. The end of the Permian period looked completely different from how we are used to imagining the ancient land. All the continents were pushed into one giant supercontinent, Pangaea, surrounded by a single ocean, Panthalassa. On land, synapsids, the ancestors of mammals, reigned supreme, and not dinosaurs, which did not yet exist. Among them were gorgonops, bear-sized predators with fangs as long as an adult's palm. They occupied the top of the food chain and had no competitors for millions of years. Parasaurs roamed nearby, massive plant-eating creatures with lumpy armor on their skin, looking like a cross between a hippopotamus and a tank. And in the shadows of the bracken forests hid small cynodonts, nimble animals the size of a rat. It is from them that in hundreds of millions of years, all the dogs, cats, horses, and people on this planet will descend. But then they were nothing, just small prey for those who were larger and stronger. Giant reef systems flourished in the oceans, which in terms of diversity of life were not inferior to modern coral reefs. Crinoids, brachiopods, and ammonites filled every layer of the water column from shallow coastal waters to deep depressions. Trilobites, legendary creatures that had previously survived 4 mass extinctions over 270 million years, seemed virtually immortal. The world was complex, rich, and resilient. It has survived ice ages, continental collisions, and falling sea levels. And so this world was erased almost entirely in a geological instant. What could destroy a planet that had withstood impacts for hundreds of millions of years? The answer lies under our feet, more precisely under the territory of modern Siberia. Approximately 252 million years ago, the Earth's crust in this region began to break apart. But this was an unusual volcanic eruption, not a cone of glory, as we are used to seeing in pictures. The Earth cracked for thousands of kilometers, and magma began to pour out of these cracks. Geologists call these Siberian ladders, from the Swedish word trap, meaning stairs, because the solidified lava formed step plateaus. The area covered by these eruptions was about 7 million square kilometers. This is larger than the entire territory of Western Europe, from Portugal to Finland. If you think you've seen scary footage of eruptions, forget about them, because here the scale was cosmic. Imagine an area the size of Australia with hot rock flowing through every crack. And this continues not for days, not for years, but for hundreds of thousands of years. Rivers of lava, tens of kilometers wide, flooded everything in their path. The air temperature near the faults rose so much that the rocks melted even before contacting the magma. Ash from these eruptions is found today in geological layers around the world from Antarctica to Canada. Clouds of emissions enveloped the entire planet, and the Earth's atmosphere darkened for months. But lava itself was not the main killer. It destroyed all life in the eruption zone. However, the eruption zone is not the entire planet. The real killing mechanism was invisible. Siberian drains released colossal amounts of carbon dioxide, sulfur dioxide, and halogens into the atmosphere. Write in the comments what country you are from. It would be interesting to find out where they are watching us from and who is equally interested in this topic. The first wave was sulfur. Sulfur dioxide rose into the stratosphere and became an aerosol that reflected sunlight back into space. The temperature on the planet dropped sharply, a volcanic winter set in, and ecosystems accustomed to the warm Permian climate began to collapse. Plants on land died from the cold, herbivores lost their food supply, and the entire food chain collapsed behind them. But the aerosol does not last long in the atmosphere. Several years, a maximum of decades, but carbon dioxide has not gone away. It has been accumulating for centuries after centuries. When the sulfur curtain settled, the exposed planet found itself under a blanket of evaporative gases, and rapid warming began. According to geochemical studies, the average temperature on Earth has increased by 8 and possibly by 10 degrees Celsius. For comparison, today scientists are sounding the alarm about a warming of 1.5 degrees, but here was 6 times more. The oceans have warmed so much that they have begun to lose dissolved oxygen because warmer water holds less gas. The depths of the oceans became anaxic, that is, completely devoid of oxygen. Marine organisms, which for millions of years breathed oxygen from the water, began to suffocate in the literal sense of the word. The corals, which need oxygen to build their skeletons, were the first to die, and the reefs crumbled like houses of cards. They were followed by mollusks and marine arthropods, deprived of shelter and food. The ocean, which had been the cradle of life for hundreds of millions of years, was turning into a warm, sour, and dead soup. If you want to know what happened next, subscribe so you don't miss news stories. Because we have not yet told the worst thing about this disaster. But even the suffocation was not the last blow, because then a mechanism was activated that causes insomnia for modern climatologists. In the oxygen-free depths, anaerobic bacteria flourished, organisms that do not need oxygen. Among them were green sulfur bacteria, which produce hydrogen sulfide during their life processes. This is the same gas with the smell of rotten eggs, only in concentrations that are lethal to all living things. Hydrogen sulfide began to rise from the depths of the ocean and enter the atmosphere. Paleontologist Peter Ward from the University of Washington hypothesized that the sky over the oceans changed color at this time. It could have acquired a greenish or purple tint due to the mass of hydrogen sulfide bacteria multiplying in the water. Imagine this picture: a green, poisonous sky over a dead, hot ocean, and a crimson glow of lava rising from cracks in the ground beyond the horizon. This is not a scene from a science fiction movie. This is a reconstruction of what the Earth looked like 252 million years ago. Well, hydrogen sulfide in the atmosphere triggered another round of destruction. It began to destroy the ozone layer, the very shield that protects all living things from ultraviolet radiation from the sun. Plant spores from this period, found in geological layers around the world, bear traces of mutations caused by ultraviolet radiation. This means that even those organisms that survived cold, heat, suffocation, and poisoning found themselves under the flow of cosmic radiation without protection. The Earth has ceased to be suitable for life at all levels simultaneously, in water, on land, and in the air. Each subsequent blow was worse than the previous one, and each new factor strengthened the others. Scientists call this a cascade of positive feedback, when the system destroys itself at an increasing rate. If it amazes you how one eruption could set off such a chain reaction, write what you think about it. Which version seems most convincing to you? But in 2015, a group of researchers from the Massachusetts Institute of Technology published a paper that added a new layer of horror to this picture. They discovered that the volcanic magma of the Siberian ramps, on its way up, passed through a layer of rock rich in coal, oil, and limestone. The hot magma literally set these deposits on fire, and they began to burn underground. Imagine a fire that breaks out not on the surface, but deep in the Earth's crust at a depth of several kilometers. It cannot be extinguished because the fuel and fire source are all around. The combustion of organic rocks released additional volumes of carbon dioxide, methane, and toxic compounds into the atmosphere. Researchers found traces of fly ash in Siberian rocks of that period, characteristic of coal combustion and not a volcanic activity. This is direct evidence that an underground fire of a planetary scale was raging underground. In fact, the Earth burned through its own fossil fuel reserves long before the first man appeared. The same oil and the same coal that we extract and burn on an industrial scale today have already burned once. This happened 252 million years ago, and the result was the almost complete destruction of life. In 2018, an international team of geochemists discovered abnormally high concentrations of mercury in the Permian Triassic boundary layers around the world. Mercury is a marker of major volcanic events. Traces of it have been found in rocks from Canada to China, from Australia to Greenland. This means that the poisoning was global. Not a single corner of the planet remained clean. But the most alarming discovery in recent years is that the extinction was not one catastrophe, but two. Research by Chinese and American paleontologists has shown that about 60,000 years passed between the first and second waves of extinction. The first blow hit terrestrial ecosystems, the second hit the ocean. 60,000 years between two impacts seems like a long time by human standards, but for evolution it is negligible. This was enough for the surviving species to begin to restore populations, begin to develop vacated niches, and begin to build food chains again. And then everything repeated itself, and the second blow turned out to be even more merciless because it hit organisms already weakened by the first catastrophe. This means that life on Earth tried to recover after the first impact, and she almost succeeded. But the planet struck again, and this time the survivors had nothing to cling to. Trilobites, which existed on Earth longer than any other complex animal, disappeared forever. 270 million years of evolution survived 4 mass extinctions, and it all ended in the Permian sediments. Gorgonopsians and most of the large synapsids were wiped off the face of the planet. Reef ecosystems, which would then take 10 million years to recover, ceased to exist. On land, entire forests disappeared, and their place was taken by mushrooms that fed on deadwood. In the geological layers of the early Triassic, paleontologists find the so-called mushroom peak, a layer in which fungal spores predominate over plant pollen. This means that a time came on the planet when there was more dead than living, and organisms that process corpses became the main owners of land. Some scientists describe the early Triassic Earth as a graveyard planet where the only thriving life forms were scavengers and fungi. The Earth has become what paleontologists sometimes call a dead zone. This is a period of millions of years when the geological record contains almost no traces of complex life. Temperatures remained extremely high for another 5 million years after the peak of the disaster. It was so hot at the equator that large animals physically could not survive there, and the tropics turned into a lifeless zone. Life glimmered only closer to the poles, where the temperature, at least a little, allowed breathing. But it was from these ashes that everything we know grew. The few synapsids that survived were small, inconspicuous, rat-like. What saved them was precisely what made them insignificant: their small size, ability to hide in holes, low need for food and oxygen. Those qualities that were considered weaknesses for millions of years suddenly turn out to be the only ticket to survival. It is from them that, millions of years later, all mammals, including us, will descend. Archosaurs, another group of survivors, would occupy the deserted land and eventually give rise to the dinosaurs. The Perm disaster acted as the greatest natural selection in history. She killed the strong and left alive those whom no one noticed. It turns out that dinosaurs, mammals, and ultimately man exist only because the Permian disaster cleared the stage. Without the Great Extinction, evolution might have taken a completely different path, and intelligent life might never have emerged. We live in a world that was born out of the largest biological disaster in the history of the planet. Every species, every tree, every animal around us is a descendant of those few who managed to survive hell. And this is what really makes you think. The mechanism of the Great Extinction was not some unique cosmic event. It was not an asteroid that flew from the depths of the solar system. It was carbon dioxide, it was warming, it was the acidification of the oceans and the loss of oxygen in waters. The same processes that are recorded by climate scientists' instruments right now in the 21st century. The difference in scale is still enormous, but the direction coincides with frightening precision. Do you believe that humanity is capable of learning from mistakes that are 252 million years old? Or are we doomed to repeat other people's scenarios? Oceanologist Lee Camp from Pennsylvania State University published a landmark paper in 2005. He showed that at a certain warming threshold, the ocean is capable of switching from an oxygen regime to a hydrogen sulfide regime. This threshold is not as far as we would like to believe. Hundreds of thousands of Siberian traps erupted to bring the planet to the point of no return. We've been emitting carbon dioxide into the atmosphere for only 200 years, but the speed of this process is frightening. In some estimates, it is comparable to that ancient catastrophe. In 2021, a team of scientists from the University of Burgos in Spain carried out a simulation. The results showed that carbon dioxide concentrations by the end of this century could reach levels not seen since the late Triassic. The oceans are already losing oxygen. This process has been recorded by monitoring stations in the Pacific and Atlantic Oceans. Dead zones in coastal waters, where oxygen falls below the survival threshold for marine animals, are growing every decade. Over the past 50 years, their area has quadrupled. The mechanism is familiar. Only this time factories, power plants, and cars work instead of Siberian gangways. Paleontologist Peter Ward called hydrogen sulfide extinctions the #1 killer in Earth's history. According to his calculations, of the 5 largest mass extinctions, at least 3 were caused by this mechanism. Volcanoes, carbon dioxide, warming, loss of oxygen, hydrogen sulfide, and again in a circle. The asteroid that killed the dinosaurs turns out to be the exception, not the rule. The rule is much scarier because it means that the planet is capable of killing itself without help from space. The Earth keeps in its depths the chronicle of every catastrophe, and the Permian border is read most clearly. Geologists find it in rock sections of southern China, in the cliffs of the South African Karoo, and in the rocks of Italian Dolomites. Everywhere the same picture. The rich, varied layer of Permian life ends abruptly, and emptiness begins above it. A thin layer of rock in which life ends, and then for a long, painful time, millions of years begins to appear again. This layer is on every continent, as if the planet left the same record everywhere. Paleontologist Douglas Irvin of the Smithsonian Institution has dedicated his career to studying the Permian Extinction. He said the event was so disruptive that it changed the very rules of evolution. The message written in the stone is very simple. Everything that seems eternal can end. 300 million years of evolution burned away in a geological instant, and the only thing left was a thin gray stripe in the rock. But it was from this strip that everything we call life grew. We are not nature's first attempt to create a complex world, but so far we are the only attempt that can read stone. And it's up to us whether this warning becomes the last lesson or the first decision.